Millions of people around the world work in tall buildings. Not many people know it, but in many of these tall buildings, there is a secret device protecting the people inside. Without this device, buildings would collapse during the event of an earthquake or due to the forces exerted by the wind. There are many different types of damping, but in this video I will just talk about tuned mass damping, how it works, the theory behind it, an example of a building where it is used. Tuned mass damping uses a large pendulum to counteract horizontal forces. To model this, you can use oscillation equations. An oscillator is a system that when you displace a mass from its equilibrium position, you will experience a restoring force. This is given by the equation acceleration equals minus 2 pi f all squared times the distance from equilibrium position. The negative sign shows that the force is always opposing the direction of motion. For a pendulum, the weight of the mass provides this force. Swapping the acceleration for force over mass using the equation F equals ma and calling 2 pi f all squared a constant, you can see the relationship between F and x is proportional. So if a pendulum was to be set up in a tall building, this theory could explain how the pendulum could act as a damper for when the building experiences horizontal motion or acceleration. The pendulum is usually placed at the top of the building because there is a larger inertia force at the top as the building sways more during an earthquake or because of winds. These two graphs show how the building will perform with and without damping. As you can see, without damping, the amplitude is greater and the time it takes for equilibrium to restore is longer. If this was the case in a building, there would be too much stress placed on the structure, which would cause it to weaken over time and eventually cause it to fail. Damping reduces the amplitude of oscillations, which means that the users of the building in the upper floors will not be affected. It is important to match the resonant frequency of the damper to the building so that when the building moves one way, the pendulum moves the other. An example of where this concept is used is in the Taipei 101 building in Taiwan. The Taipei 101 building is 509 meters tall and the 8th tallest building in the world. From the 87th floor to the 91st floor, there is a huge ball acting as a giant 4-story pendulum, effectively damping the whole building. This is the world's largest tune mass damper. The tune mass damper does not completely eliminate movement, but it certainly makes a difference. It is through this innovative engineering like this that allows skyscrapers to be built in earthquake-prone areas.